Hi, I recently produced a video disclosure called Revised Relativity that shows that the theory of relativity is not only evident, but is essential in the low-speed orbits of all satellites. As outrageous as it may sound, I back it up with 10 points that verify its feasibility. In one of these points, I credit relativity for replenishing the inertia that satellites lose to centrifugal force while in their orbits. It's my opinion that if you want to enjoy the 1g of continuous centrifugal force that's necessary to keep a satellite in orbit, you have to apply 1 continuous g of acceleration. I also concluded that as a satellite's orbital speed increases and decreases, so does its gravity, which creates a whipping motion which overcomes the inertial loss to centrifugal force. Just like with a ball on a string, oscillating gravity continually whips satellites around in their orbit. With each orbit, the oscillating gravity replenishes the inertial loss to centrifugal force. If you stop this whipping action, then it's not long at all before the satellite loses its orbit. To test the water on the theory, I posted the video on YouTube and then posted a link to it on several physics chat forums. Half of the negative feedback that I received was because my understanding of centrifugal force didn't agree with the popular understanding of centrifugal force. So I produced this short video to make my understanding of centrifugal force clear. My critics from the online forums said that I was wrong about centrifugal force, that centrifugal force does not rob satellites of their inertia. They went on to say that if you spun an object in outer space where there's no friction or wind resistance to slow it, that it would spin forever. To them, centrifugal force is centrifugal force. But in my way of thinking, centrifugal force has two very distinct forms. There's counterbalanced centrifugal force, to where you have two objects that are equal and opposite in mass, orbiting an axis, producing an equal and opposite centrifugal force. The centrifugal force of each of the objects cancels out the centrifugal force of the other. This greatly reduces centrifugal force from the equation, creating an apparatus that's ideal for inertia storage. And then there's unbalanced centrifugal force, to where an orbiting object is not coupled with an opposing object which can counter the centrifugal force it's experiencing. It doesn't matter if the object's being forced into a circular path by an inside axis or an outside race. The apparatus that causes the deflection will absorb the object's centrifugal force. But you don't need to take my word for it. If you want to see an example of this, you only need to go as far as your washing machine. If your load is balanced, this is what you should see on your spin cycle. Counterbalanced centrifugal force. But then shift all your load to one side, and this is what you'll see. Off-balanced centrifugal force. So an example of counterbalanced centrifugal force, aside from a washing machine, would be like in a flywheel, which again is a perfect means for inertia storage. And a perfect example of off-balanced centrifugal force would be that of a satellite in orbit. Satellites have no counterbalance, so they would lose their inertia to centrifugal force. So I don't think my critics were comparing apples to apples. In order to understand centrifugal force, I had to figure out how and why it behaves as it does. I started with the understanding that whether it's accelerating or coasting, an object will travel in a straight line unless it's otherwise deflected. If a force of 1g is applied to an object, it will accelerate at 32.2 feet per second. If the object's path is blocked by an object of equal mass, then that new object will absorb half of that 1g of acceleration. And then both objects will be accelerating at 1/2 a g. So the original object was deflected from its path with a 50% deflection. If the object with 1g of acceleration acting on it came in contact with a solid, immovable wall, it could no longer accelerate. The force of 32.2 feet per second will have been entirely absorbed by the wall, and at the end of 1 second, the object will not have moved from its original position. So this, I would consider to be a 100% deflection. I look at centrifugal force as circular deflection, whether it's 50%, 100%, etc. In my way of thinking, if an object travels 32.2 feet in 1 second and it's been deflected back to the exact point where it began, then it's experienced a 100% deflection. So 100% of 32.2 feet per second equals 1 G. I use that for a standard for an easy way to calculate centrifugal force. If I've managed to convince you in the last 5 minutes that satellites indeed lose their inertia to centrifugal force, you may want to watch my video, Revised Relativity, to find out how that inertia is replenished.